Hi, this is the Science Chef. In this video, we'll be learning about the hydrolysis of salts with examples of salts that undergo hydrolysis in the 9th part of a series on acids, bases, and salts. Please go nowhere, and we'll be right back after this break. In our tutorial on methods of salt preparation, we learned that one of the methods of preparing soluble salts is from the reaction between acids and bases. However, the nature of the salts when dissolved in water depends on the strength of the acids and bases that reacted. To learn more about acids, bases, and salts, check the link in the description. Ordinarily, when normal salts dissolve in water, one would expect them to give a neutral solution with a pH of 7. But this is not always the case, as some of them dissolve to give acidic solutions, while others give alkaline solutions. This is known as the hydrolysis of salts, and is defined as the phenomenon in which salts react with water when dissolved in it to form acidic or alkaline solutions. When this happens, we say the salt has undergone hydrolysis. So let's look at the categories of salts that can be formed based on the strength of the parent acids and bases and the effect of their dissolution on litmus paper. The first category is salts of strong acids and strong bases. Salts of strong acids and strong bases do not undergo hydrolysis because when dissolved in water, though they react with the water molecules to form their corresponding acids and bases, the equal concentrations of the hydrogen and hydroxide ions in the salt solution will counterbalance each other, thereby making the solutions neutral and their pH equal to 7. This is because, being strong acids and bases, they will ionize completely in solution and none of the hydrogen or hydroxide ions will be in excess concentration in the solution. Examples of salts of strong acids and strong bases are sodium chloride formed from sodium hydroxide and hydrochloric acid, potassium sulfate formed from the reaction between potassium hydroxide and sulfuric acid, sodium nitrate, etc., formed from sodium hydroxide and nitric acid. You may need to watch our tutorials on definitions and properties of acids and definitions and properties of bases to see examples of strong and weak acids and strong and weak bases. The next category is salts of strong acids and weak bases. This category of salts undergoes hydrolysis when dissolved in water to form solutions that are acidic with pH less than 7 and turn blue litmus paper red. This is because they react with water to form their corresponding parent acids, which ionize completely in solution, and weak bases, which undergo partial ionization, as a certain percentage of the bases will exist as molecules in the solution, thereby making the concentration of the hydrogen ions in the solution higher than that of the hydroxide ions. As such, the hydrogen ions predominate in the solutions and account for their acidity. Examples of salts of strong acids and weak bases are ammonium chloride, a product of ammonium hydroxide and hydrochloric acid, zinc sulfate, formed from the reaction between zinc hydroxide and sulfuric acid, magnesium nitrate, etc., a product of magnesium hydroxide and nitric acid. The next category is salts of weak acids and strong bases. Salts of weak acids and strong bases undergo hydrolysis in a manner that is completely opposite to the last category we just discussed. They undergo hydrolysis in water to form alkaline solutions with pH greater than 7 and turn red litmus paper blue. They react with water to form their corresponding weak acids, which do not ionize completely in solution, and strong bases, which ionize completely in solution. Just like weak bases, a certain percentage of the weak acids will exist as molecules in the solution, thereby making the concentration of hydrogen ions in the solution lower than that of the hydroxide ions. By so doing, the hydroxide ions become prevalent in the solutions and account for their alkalinity. Examples of salts of weak acids and strong bases are sodium carbonate, a product of sodium hydroxide and carbonic acid, potassium phosphate, formed from potassium hydroxide and phosphoric acid, sodium ethanoate, etc., formed from sodium hydroxide and ethanoic acid, The last category, the source of weak acids and weak bases, is merely discussed in the hydrolysis of salts, as the dissociation of their acids and bases are too insignificant to affect the pH of the salt solutions. Simply put, they do not undergo hydrolysis. Examples of such salts are calcium phosphate, ammonium carbonate, copper 2 ethanoate, magnesium sulfite, etc. In our next tutorial, we'll be learning about effervescence, deliquescence, and hygroscopy, with examples of substances that exhibit this phenomenon. If you'd like to be notified when the video is published, subscribe to our channel and turn on the notification bell. Remain on top until I see you when I'll see you.